My name is Shreya HK from Sri Venkateshwara College of Engineering, and today I will be explaining the topic related to chemistry, that is nothing but corrosion. Corrosion is a natural process in which a refined metal is converted to a more chemically stable form such as oxide, hydroxide or sulfide. It is the gradual decomposition of materials as a result of chemical or electrochemical reaction with their surroundings. A few general examples of corrosion are the rusting of iron, tarnishing of silver, and the appearance of green color in copper. Due to corrosion, lots of buildings, bridges, and ships that are constructed using iron get affected. Here we can see in the picture where corrosion of silver metal, where we can see that polished silver get converted into the tarnished silver. Rusting of iron, the combination of iron, oxygen and water which gets converted into hydrated iron 3 oxide, which is nothing but rust. Dry corrosion or oxidation occurs when oxygen in the air reacts with metal without the presence of a liquid. Here we can see in the picture, which is example for dry corrosion. Wet corrosion of metals occurs through electron transfer involving two processes, oxidation and reduction. In oxidation, the metal atoms lose electrons. The surrounding environment then gains the electrons in reduction. The metal where electrons are lost is called the anode. Here is the picture where we can see the wet corrosion example. Electrochemical theory of corrosion. Electrochemical theory, where we take iron as the example. The rusting of iron is a slow process in which the iron reacts with oxygen and forms an iron oxide, which is usually reddish brown in color. We usually study the Nernst equation and related numerical in electrochemistry. According to the electrochemical theory of the rusting of iron, oxidation reaction occurs at anode and reduction reaction occurs at cathode. At the anode, the iron is oxidized to the ferrous ions and the electrons which are released move towards the cathode. At the cathode, here we can see the reaction, that is Fe gives Fe2 plus 2 electrons. At the cathode, the hydrogen ions are taken from the moisture that is present in the atmosphere. So the reaction of water releasing hydrogen ion is H2O gives H plus OH minus. At the cathode, where reaction is H plus electrons gives H, but the oxygen that is present on the surface of the iron is reduced by hydrogen. So the reaction becomes 4H plus O2 plus 4 electrons, that is nothing but 2H2O. Hence, by using the oxidation and reduction half reaction, we can write the overall reaction, that is 2Fe plus 4H plus O2 gives 2Fe2 plus 2H2O as the reaction. This ferrous ion is further oxidized by the oxygen which forms the rust, that is 4Fe2 plus O2 plus 4H2O and 2FeO3 plus 8H plus where in the reaction it occurs. Two methods to prevent the rusting are: if we will paint the metal, then it reduces the chances of rusting by separating the metal from the water. We can also use oil or grease to keep the water away from the iron. Types of corrosion, that is differential metal corrosion. It occurs when two dissimilar metals are in contact with each other in a corrosive conductive medium. A potential difference is set up by resulting in a galvanic current. The two metals differ in their tendencies to undergo oxidation. The metal with lower electrode potential or more active metal acts as anode, and metal with higher electrode potential acts as cathode. The potential difference is main factor for corrosion to take place. The anodic metal undergoes corrosion whereas cathodic metal gets unaffected. Examples are: when iron is in contact with copper, iron has lower electrode potential, acts as anode and undergo oxidation as Fe, that is nothing but iron. Copper, having higher electrode potential, acts as cathode and is unaffected. Depending on the corrosive environment near the cathode, either hydrogen evolved or oxygen absorbed, resulting in hydroxide ion formation. Differential aeration corrosion often happens in steel guttering that isn't sufficiently protected or kept clean and clear from blockage. Standing water in a gutter system combined with a coating that isn't adequately protecting the metal will result in the formation of corrosion along the water line. The same applies to metal tanks and pipes. If water or a corrosive liquid is allowed to stand where there is a good supply of oxygen, the electrochemical reaction will occur. Other instances would be when a water droplet settles on the exposed steel. The area below the water droplet is low on oxygen, while the surrounding area has plenty of oxygen from the air. This creates a cathodic and anodic reaction. The cathodic reaction depletes the oxygen beneath the water droplet. This area is now anodic and starts to corrode, forming a pit. Thank you.